Hello everybody and welcome to this presentation from Richard van Rijn, who's CTO of Applied Nanolayers, and Richard is going to give us a talk on scalable production and integration of graphene. As always, we'll be taking your questions live at the end of the talk, so please leave them in the sidebar as indicated. I'll now hand over to Richard and I'll reappear again at the end. Over to you.
Thank you very much, Chris. Yeah, good afternoon, everybody. My name is Richard van Rijn. I'm the CTO of Applied Nanolayers, and I will talk to you today about the scalable production and integration of graphene. So, Applied Nanolayers is a company, 15 people based in Delft in the Netherlands, and we set ourselves a challenge of solving the integration problem of graphene. So here on the left, you can see the first transistor, which is a very, very bulky thing. Which in the end led to a $450 billion semiconductor industry. And on the right, you can see graphene as it was first exfoliated from graphite. And if we want to have all the fancy graphene applications, we somehow have to integrate that with the semiconductor industry. So how do we go about doing that? Well, we have developed a graphene technology platform where we offer a complete package. So we have industry-compatible graphene growth, transfer, and integration. Technology platform consists of tools, processes, and materials. So we have up to 200 millimeter wafer size, growth, transfer, inspection, and fabrication. We offer foundry light application support. So that's design fabrication according to a design rule manual. We have several lithography options, contact metal options, and encapsulation options for the graphene devices we make. So why would you work with us? Well, we have the full end-to-end methodology in tools, processes, and materials. Process is very reliable and robust. The tools are based on industry standard platforms. All processing is wafer-based, industry compatible. We have rigorous quality control. The platform we use is also compatible with other 2D materials such as hexagonal boron nitride and transition metal dichalcogenides, and we have a team of very experienced application scientists and process engineers that can help you make your device a reality. So the technology we have, on the growth side, we have our own CVD tools where we engineered the process and the substrates that go into that and the tool itself to be able to grow the best quality graphene that you can buy. On the transfer side, we have our own tools and processes that allow us to, at 200 millimeter wafer scale, delaminate the graphene from our growth substrates and transfer them to your substrates or any other substrates. And then we have inspection tooling. So we have optical microscopy, Raman spectroscopy, AFM, and several other inspection tools available at 200 millimeter to verify the quality of the graphene we make. And for the fabrication, we have access to clean room facilities where we can fabricate your graphene into devices. So how our process looks, we start with a growth substrate. We grow monolayer or multi-layer graphene, depending on what you need. We can then bond a temporary carrier wafer to the graphene, debond that from our growth substrate, which we can then use again. And in the simplest form, this carrier adhesive graphene combination, you can buy from us as an application development kit, in which case you can transfer yourself, or we can use that internally within the company to transfer to your substrates here in this bond step. And then we can debond the carrier wafer from the graphene and provide a wafer to you like this. So you'll get it with monolayer or multi-layer graphene transferred onto your wafer. Or we can do device fabrication for you, where we can lithographically shape the graphene into the device you want, put contact metals on or underneath the graphene, and encapsulate it as well as that's required. I'll show you some of the results that you can expect if you work with us. So here is optical microscopy data of graphene coming out of our process. We have an automated microscope where we can essentially image the whole wafer. This is a 50 times magnified image of one of the areas on such a wafer.